Hello guys, you're welcome to our chemistry class today. In today's video, we are looking at how to balance a chemical equation. A good knowledge of balancing chemical equation is very important because we apply them in stoichiometry. Stoichiometry is a branch of chemistry where we use a balanced chemical equation to calculate the amount of individual species that are involved in a reaction. Okay. Now, my job here is to show you a very simple and a unique method to balance a chemical equation. So, if you are seeing this video, you are very lucky. Okay, because I'll be showing you a very straightforward and a sure method to balance any uh, chemical equation. Okay, now let's start. Now, before we solve these problems here, let's understand some basic concepts. Very important. Okay, let's look at this example. This is a chemical equation. This is the reactant here, and this is the product here. Okay, now we have nitrogen here, we have hydrogen, and we have oxygen. So these are the three elements that are involved in the chemical reaction. Then here, the same thing goes, we have nitrogen, we have hydrogen, and we have oxygen are the products. Now you need to know how to count the number of atoms on both sides of the equation. Because for a balanced chemical equation, the number of atoms here for a given element must be equal to the number of atoms of the same element at the product side. Okay, so how how do we count the number of atoms? Okay, to calculate the total number of atoms of a given element is by multiplying the subscript with the coefficient of that particular species or element. Okay, look at what I mean. Okay, here we have, this is nitrogen here. How many nitrogen can you see here? We have only two nitrogen here because the subscript here is 1. We have 1 here. So when you don't have a number below the symbol of the element, we assume it to be 1. So we have 1 here. 1 times 2 is 2. So you multiply the subscript with the coefficient of that element. So 1 times 2, so we have 2 here, 2 nitrogen are the reactants. Okay, what about, so what we are doing now is atomic count. How to count the number of atoms or number of elements in both sides of the equation. Okay, here hydrogen, we have 3 as the subscript and we have 2 as the coefficients. Remember, this 2 is going for both nitrogen and hydrogen. So when you have a coefficient, it is going for all the elements in the compound. So we have 2 here. This 2 is for nitrogen and also for hydrogen. So that means the total number of hydrogen here is 3 times 2. So we have 6. Okay, that is the total number of hydrogen and the reactants. Then coming to oxygen, oxygen here we have 3 as the coefficient, that is the number in front of oxygen. Then we have 2 as the subscript. So you multiply the subscript, that is 2, by the coefficient to get the total number of the atom or the element. So we have 2 times 3, which is 6. So we have 6. Okay. At the product side, the same thing goes. Here we have nitrogen. This is our nitrogen. There is no number here. There is no letter here. There is no subscript. So we have 1 times 4, and that is 4. So we have 4 here. What about oxygen? Okay. Oxygen here, this 4 also belongs to oxygen. So we have 4 times 1 because there is no subscript here. So we assume it to be 1. So 1 times 4 is 4. Okay. So we have 4. But we have oxygen too here. We also have another oxygen here. So we have plus. This is 6 times 1 because there is no subscript here, so we assume it to be 1. This is 1 times 6 is 6, so plus 6. That means the total number of oxygen at the product side is equals to 10. So we have 10 oxygen at the product and 6 at the reactant. You see now that oxygen is not balanced. Then what about hydrogen? Okay, let's check hydrogen. So here hydrogen we have 2 as the subscript, then 2 times 6 is 12. So this is equals to 12 hydrogen. Okay, so that is how to do your atomic count. So you must know how to do atomic count before you will start balancing chemical equation. Okay, so when taking the number of atoms you have in a given site, multiply the subscript with the coefficient. And again, please, when balancing a chemical equation, don't change the subscript. Use coefficients only to balance your chemical equation. Okay, look at what I mean. Now here I have 4 nitrogen at the reactant and I have 4 nitrogen at the product side. That means I need 2 more nitrogen here to balance my nitrogen at the product. I need 2 more. So I have to change these 2 or put a number that will give me 4 here. I don't have to change the subscript here. I don't have to put, say, 2 here to make it 2 times 4. No, you don't have to change or put any subscripts to balance a chemical equation. We only use coefficients to balance a chemical equation. So don't alter any subscript. Use coefficients to balance a chemical equation. Okay, now let's look at these questions one after the other. Let's balance this chemical equation. Now the first one here we have this ammonia reacting with oxygen to give us nitrogen 2 oxide and water. Okay, so this is the first question here. So we have to balance this chemical equation. If you check now, you will see that this equation is not balanced. We have nitrogen here, 1 nitrogen here, 1 nitrogen here. Okay, so we are doing our atomic count now. So we want to check the number of individual atoms on both sides to know if the equation is balanced. Okay, so but take notes. Look at the order you have to take while balancing your chemical equation. You have to balance your metal. Metal will come first. Then we have the non-metal, non-metals. Then we have the hydrogen. And lastly, you balance your oxygen. Okay, so while balancing a chemical equation, so you have to balance the metal first, followed by non-metal, then hydrogen, and then lastly balance the oxygen. So that is the order we'll be following while doing all these things. Now, this is the first question. So the first element here, that is, we don't have any metal here, so we skip that. Then do we have non-metal? Yes, of course, we have nitrogen here. So let's check the number of nitrogen at the reactants. The number of nitrogen at the reactants here is 1. So we have only 1 nitrogen because looking at the base here, there is no subscript. This 3 is for hydrogen only. So nitrogen here has no subscript. So it's just like 1 times 1. So 1 is the coefficient because we don't have any number before the ammonia. So when you don't have a number here, it implies that you have 1 as its coefficient. So we have 1 here. The 1 here times the 1 here, we have 1. So, and that is only 1 nitrogen. So we have 1 nitrogen, okay, at the reactants. Then let's go at the products. At the product here, we have 1 also. So we have 1 times 1, and that is 1. So nitrogen on both sides is balanced. Okay, so we don't have issue with nitrogen. Then let's check the next element. The next element here is hydrogen. Okay, we have three hydrogen here, and we don't have any other hydrogen, so we have three hydrogen as the reactants. Let's check the products to see the number of hydrogen we have. We have 2. That is 2 times 1 is 2. So we have 2 here and we have 3 here. So it therefore implies that we need, so this implies that we need 3 hydrogen. We need 3 hydrogen at the what? The left hand side. So because we have 3 here and we have 2 here, sorry, at the right hand side, so we need 3 hydrogen at the right hand side because we have 3 here, so we need 3 hydrogen here. Okay, and that is where my simple trick comes. So if we need 3 here, the simple thing you just need to do, you don't need to look for a number or multiply to give you an even number, no. So you just have to put the 3 here, then divide it by the number of subscripts you have. So you have 2 here. So because we need 3 hydrogen here, so you write your 3. We need 3 hydrogen there, you write your 3. Then divide by these 2 here. Okay. So any subscript you have, that is what you put as your denominator. Okay. Now the hydrogen is balanced, but you have to clear the fraction. Okay. Because in a chemical equation, we don't allow fraction to remain in our equation. We have to clear the fraction. And to clear a fraction, you multiply every species by the denominator of the fraction. The only fraction we have in this equation is 3/2. And the denominator here is 2. Okay, so we are using 2 to multiply every species, every element involved in this reaction. So then times 2, we have 2NH3, okay, plus 2 multiplied by this, we have 2O2, okay, that is for the reactants. Now we go to the product, then multiply by 2, 2NO, then plus, then 2 multiplied by this. If you multiply 2 by this, you are having 3H2O. Yeah, 2 times 3/2, that is 2 times 3/2. This times this is not 6 all over 2. This divided by this, you will have 3. So that is how I got my 3. So that is for that. So you can see now that hydrogen is now balanced. So we have balanced the nitrogen. If you check now, you see that nitrogen and hydrogen are balanced. We have 2 nitrogen here and 2 nitrogen here. Nitrogen balance. Let's check the hydrogen. The hydrogen, we have 2 times 3, that is 6. 2 times 3 is 6. Then let's check the product side. 2 times 3, 6. So 6 hydrogen. Hydrogen is balanced. Then we are left with oxygen. Now the oxygen here, we have 4 oxygen here. That is 2 times 2 is 4. Now let's check the number of oxygen we have at the product. Here we have 2. This is 2. 2 oxygen here plus 3 is 1 times 3. We have 2 oxygen here plus we have 3 oxygen here. That is total of 5 oxygen. So we have total of 5 oxygen at the product. Then at the reactant, we have 4. Okay. 5 oxygen here, 4 here. That means we need 4 oxygen. Sorry, we need 5 oxygen at the reactant so that it will be equal to 5 at the product. So what are we going to do? So you need to put 5 here. As simple as that. So because we need 5 oxygen here, so we're going to put 5/2 here. This 5 is because we need 5 oxygen here. Then this denominator here is the subscript of that element you want to balance, or the atom you want to balance. So we are going to get rid of these two. Get rid of the denominator you have there, then insert the fraction. Okay, so this implies we are having 2NH3 plus 5/2. So we have removed this one. So we are putting the new coefficient, and which is 5/2, because we need 5 oxygen at the reactant over 2, that is the subscript here. Okay, oxygen, then to give us 2NO plus 3 hydrogen 2O. Okay, now when you have a fraction, clear the fraction. Don't leave a fraction in a chemical equation. So to clear the fraction, you have to use the denominator and multiply every coefficient or every species in the reaction. So we are having 2 times this, we have 4NH3. Okay, let's come here. If you multiply this 5/2 by 2, you are getting 5. This is 5O2. Okay, now let's go. Then this times 2 is 4NO. Then 2 will give you 6H2O. So we multiply everything by 2, 2, 2. So this is your balanced chemical equation. Check, do your atomic count, then you will discover that everything is now balanced. Let's check. Nitrogen, we have 4 nitrogen here. We have 4 nitrogen here. Nitrogen balance. Then coming to hydrogen, we have 12 hydrogen here. That is 3 times 4, because this 4 is going for nitrogen and hydrogen as well. So we have 3 times 4 is 12 hydrogen here. So let's check the number of hydrogen there. This times this is 12. So we have 12 hydrogen on both sides. So hydrogen is balanced. Let's check our oxygen. Then coming to oxygen, we have 5 times 2, that is 10. Okay. Then we have 10 oxygen at the reactant. Coming to the product side, we have this, that is 4 oxygen here, that is 4 plus 6, that is 10. So we have 10 oxygen on both sides. That is for that. Okay, let's check question number 2. Now in question number 2, we have Cu2S plus oxygen to give us Cu2O plus SO2. Okay, so now let's go. We have metal here, that is copper. We have 2 atoms of copper here, and we have 2 atoms of copper here. Okay, so that means copper is balanced. Then we have non-metal, that is sulfur. We have a sulfur atom here. We have only 1 sulfur here, and we have only 1 in the opposite side. Sulfur is balanced. Then let's go to oxygen, that is, we are left with oxygen. Okay, we have 2 oxygen here at the reactants. Let's check the products. So we have 1 plus 2. We have total of 3 oxygen at the product, 3 oxygen here, and we have 2 oxygens here. So that means we need 3 oxygen here to balance with these 3. Okay, so that means we're going to insert 3/2 here. So we need 3/2. That is, the 3 here is the number you need. So the fraction, this fraction, look at how you get this fraction, is the number needed all over the subscript, or the number of atom present. Number of atom present available. So the number needed, we needed 3 oxygen as the reactant. So I'm dividing it with the number of oxygen present, that is 2 oxygen. Okay, so that is what I'm doing here. So we need to put 3/2 here. So we are having Cu2S plus 3/2 oxygen to give us Cu2O plus SO2. Okay, so that is for that. Then you have to clear the fraction. The fraction here is 3/2. So we are multiplying everything by 2 because 2 is the denominator. So we are having 2Cu2S plus 2 multiplied by this, we have 3O2 to give us 2Cu2O plus 2SO2. Okay, so oxygen is now balanced. Okay, and everything is balanced. So let's check. We have 2 copper here, sorry, we have 4 copper here, that is 2 times 2 is 4. Let's check here, we have 4 here, balanced. Then let's check sulfur. We have 2 sulfur here. This 2 is going for sulfur. So we have 2 sulfur here, and here we have how many sulfur here? We have 2 sulfur, that is 2. This 2 is not going for sulfur, this is for oxygen, so we have 2 sulfur here. So 2 sulfur here, 2 sulfur here. Sulfur is balanced. Then for oxygen here, we have 6 oxygen here. We have 2 times 3, that is 6. Okay, let's check the number of oxygen at the product side. We have 2 oxygen, that is 2 here. Then plus how many here? We have 4. So which gives us the total of 6. So we have 6 here and 6 here. Okay, 6 are the reactants and 6 are the product. That means oxygen is balanced. So everything is balanced. So, and that is for this equation. Okay, so you can see that in this method, you don't have to go back and balance any given element due to addition of, because you have added a coefficient. No, so that is one of the advantage you have using these methods to balance your chemical equation. So you don't need to go back and balance atom because you added a coefficient. No, this is straightforward, man. Okay, let's go to question number 3. In question number 3, we have hydrogen reacting with oxygen to give us H2O, that is water. Okay, this is a simple equation. Okay, but let's do it. Now you have this. Let's do our normal atomic count. We have 2 here. We have 2 here. Hydrogen is balanced. 2 hydrogen here. 2 hydrogen here. Hydrogen is balanced. Then let's go to oxygen. You have 2 oxygen here and 1 oxygen here. Whew. Okay, so 2 here and 1 oxygen here. So it therefore implies that we need 2 here, we need 2 oxygen here, or we need 1 oxygen here. If we have 1 oxygen here, then oxygen will be balanced in both sides. So let's have 1 here. Okay, that means we have to multiply here with 1 and then put over 2. Yeah, so we are having 1/2 as the fraction that we're going to place as the coefficient of oxygen to balance it, because we need 1 oxygen here. We need only 1 oxygen to balance 1 oxygen at the product. So we are inserting H2 plus 1/2, that is, we need 1 oxygen, then this 2 is the subscript of the oxygen. Okay, then to give us what? H2O. Okay, now let's clear the fraction. Let's remove this fraction by multiplying everything by the denominator of the fraction. That is 2. So we use 2 to multiply 2. We have 2H2 plus 2 multiplied by this will give you 1. That will give you oxygen. So we have 1, but you don't need to write your 1 there. So we have Then 2 multiplied by this, we have 2H2O. Okay, is that not simple? Okay, so let's check. We have 4 hydrogen here. We have 4 hydrogen here. Hydrogen is balanced. Then we have 2 oxygen here, and we have 2 oxygen here. Oxygen balance. Okay, then let's go to question number 4. In question number 4, we have potassium triisochlorate, potassium triisochlorate. Then giving us, when it decomposes, it will give us Cl, potassium chloride, plus oxygen. Okay, so in this reaction, let's look at how it goes. Now we have potassium here, 1 potassium here, 1 potassium here. Potassium is balanced. Then chlorine here, we have 1 chlorine here, we have 1 chlorine here. Chlorine is balanced. And let's look at oxygen. We have 3 oxygen here, and we have 2 oxygen here. So we have 3 oxygen here, we have 2 oxygen here. Okay, so we need 3 oxygen here at the product side. Okay, so it therefore implies that we are adding 3/2 here. Okay, we are adding 3/2 here. Okay, so let's go. KClO3 will give us KCl plus 3/2 oxygen, because I need 3 oxygen at the product, and this is the 3 here over 2, that is the subscript on what I have. So now the equation is already balanced, but we need to clear the fraction. Okay, so multiply through by 2, that is the denominator of the fraction. So we have 2KClO2 to give us 2KCl plus 3O2. If you multiply the whole of this by 2, you are having 3. So, and that is the balanced chemical equation. If you check, do your normal atomic count, the equation is balanced. Okay. Then the last equation, here we have number 5, we have C8, then H18 plus what? O2 to give us CO2 plus H2O. Okay, the same thing goes. Okay, now coming here, we have 8 carbon here, and here we have only 1 carbon, so we have to add 8 here. Okay, we are adding 8 here, so we have C8H18, then plus O2 to give us 8CO2, then plus H2O. Okay, fine. Mind you, I'm adding 8 here, that is 8/1. I'm adding 8/1. That's the fraction, because I have 8 here, I have 8 carbon here, and I needed 8 carbon here. So, and that means I'm adding 8/1. The coefficient of carbon here is 1, so that is 8/1 you get. Okay, so that is what I did, get my this. So, but all over 1, you don't have to put over 1, you know. So that is it. Now, from here now, carbon is balanced. We have 8 carbon here, 8 carbon here. Let's go to hydrogen. In our hydrogen, we have 18 hydrogen here. Then coming to the product side, we have only 2. So it therefore implies that if we have 18 hydrogen here and we have 2 here, we need to put 18 here. We need 18 hydrogen here to balance the hydrogen at the reactant side. So we need 18. So we have to put 18 here all over 2. 18 over 2. So let's go. We have C8H18 plus O2 to give us what? 8CO2 plus 18 over 2H2O. 18 divided by 2 is not even a fraction. It's not a fraction. That is 9. So 18 divided by 2 is 9. So he is not giving us a fraction. So it's the same thing as 9. Okay. Then hydrogen is balanced now. Then let's go to the last element, which is oxygen. Oxygen, here we have 2 oxygen at the reactants. Then at the product we have this times this, we have 16 here. 2 times 8 is 16, then plus 9, which is equals to 25. So we have a total of 25 oxygen at the product, and we have only 2 at the reactant. So we have 2 here and we have 25 at the product side. So we have to add 25 here. We need 25 oxygen here to balance with the one at the product side. So that means we are adding 25 over 2. So we're going to put C8H18 plus 25 over 2 oxygen to give us 8, having HCO2 plus 9 H2O. Okay, now we have a fraction, so we have to multiply through by 2 to clear our fraction. We're having 2C8H18 plus, if 2 multiply this, we are having 25 O2 to give us 16 CO2 plus 18 H2O. Now do your normal atomic counts. Everything is balanced. Okay, so let's go. This is 2 times 8 for carbon, that is 16. So we have 16 carbon here at the reactants. At the product here we have 16 carbon. You can see 16 carbon. Then let's check hydrogen. Hydrogen, here we have 2 times 18 is 36. So we have 36 hydrogen here. Let's know if we have 36 there. So let's go. We have 18 times 2, 36 hydrogen balance. Let's go to the final, which is oxygen. Okay, here we have 20. This times this is 50 oxygen. Then coming here we have this times this, 16 times 2 is 32. Okay, then 32 plus, we also have 16 here, 32 plus 18, that is 18 oxygen, that is 50. So we have 50 here and we have 50 here. So oxygen is balanced. So everything is balanced. So with this, you don't have problem, you don't have issue with balancing chemical equation. So this is the kind of thing I'll be giving to you in this channel. So if you have not subscribed to this channel, please do so. Do yourself well to click the subscribe button and make sure you watch our video. Thank you.